Hey everybody, this is Larry. This is me going with Q4 of the weekly contest 366. Apply operations on a way to maximize sum of squares. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem or this problem, Q4. So hit all the like buttons and all the buttons. Leave a comment if you like in the comments. I think for this one, to be honest, I think some of it is that, you have this weird thing. I solved this in 4 minutes or less than 4 minutes even. But to be honest, some of it is that I've seen kind of this operation before. I don't remember if it's this problem, but that probably doesn't even matter that much because if I did, I wouldn't have remembered it. But this operation that I'm highlighting, I definitely remember it. And that's how I was able to solve it so fast. And what this operation is a very funky, very obfuscated way of just writing certain things, right? And the idea here, and I think, spoiler alert, sorry friends. And what I think for this particular problem, and if you don't have the experience that I had for this particular problem, I actually, to be honest, still wrote it down in a notebook just in case. But the core idea is that these are all bitwise operations. And what I mean by that is that, you don't have to worry about all the numbers. You just have to worry about each bit by each bit, right? And so what I mean by that is that you can write a truth table. And that's basically what I did on the paper. Except for that, I knew that the or and the and doesn't really make sense for 0 and 1s, or we could write it out just for completion, and we will. And then here, so then now let's say new I and new j, right, is going to be 0, 0, right? Just trivial for this case. And then now you have 0, 1. It's going to be I forget which one is it. I actually, to be honest, during the contest, I was just like, it doesn't really matter which one it is, but you basically give one to the other. The idea here is basically this is the operation afterwards, right? Maybe I'll add an arrow just to, I don't know if that makes it clearer. But basically after one operation, this is what happens. And the way that I think about it is that, okay, what this function is saying, and some of this is, like I said, from practice, where like as soon as I saw this, I was like, oh yeah. So basically just giving bits from one number to another. And you could do this any number of times. That means that you want to kind of, so you can give all the digits or all the ones to numbers that need it, right? And in that sense, it's going to be greedy. There's a thing about like summing. So if you don't have a square, then I don't know, then you could just actually nothing really changes because of, is it commutative or one of the distributive, some of those laws for addition. So then you don't have to worry about it. But because it's a square or which is a multiplication thing, it just turns out the other thing that I know, and maybe a lot of you will know just from practice and stuff like this, is that there are a lot of random properties in math and things that in competitive that just comes up. But for example, would you rather have 3 square or 1 square plus 2 square or something like this, right? And obviously, in a greedy way, you actually want the 3 square instead of this, something like this, right? So basically, here in a greedy way, what we have is an operations that just puts all the 1 bits into the same place. Because now here, given this truth table, I'm thinking one level is okay. I said that all the bits don't matter independently of each other, but now when we couldn't combine them, it all in a greedy way, it all makes sense to put them on the same number versus splitting them out in 2 numbers because of the thing that we just showed. In a greedy way is that the more you have, the bigger the n square is, right, or x square is. So that's basically the idea. So from those 2 parts, I was able to kind of get very quickly to, now you have the greedy on basically creating the biggest number possible and you take k of them. And I didn't actually implement this the slickest way or the time complexity optimal way, but this is fast enough for a contest. We'll go with my thing and what I could have done to make it better. But, like I said, for a contest, it doesn't matter. And also I did this in 3 minutes and 20 seconds, right? So basically, first of all, don't forget the mod. And you can watch me solve it live next as well, so be careful with that. But basically here is that I just deconstruct every number into the bits. So basically I have 32 bits. For each bit, I check to see if there's a 1 there. And if there's a 1, then we have, we just literally count the number of bits in each position. And then in a greedy kind of way, for each number that we got, we put it back together. like a robot or something. I guess I don't know. I'm not very good at analogy today, but yeah, you put it back together, and this is done in a very greedy kind of way, which means that for the biggest number or for the earliest number, I think this. I don't even think I need to sort this, but I think I was just doing it just to be sure, to be honest. Because yeah, for a greedy reason, all the numbers will be on in the front. But I think I was just like, I don't know. But yeah, but in this case, like I said, as long as we have a bit, we give it to the first number that we see in a greedy way. So kind of, if you kind of, the way that I want to visualize it is that you have some numbers that are like, and kind of think about these numbers as vertically, right? Like so maybe you have like something like this, right? I don't know, right? And then now the idea is now, and the number one number is vertical, and then now the idea here is now shift everything to the left. So then now it's almost like putting it like this. Yeah. So then now you have this number. The first number will be, what is it, 615 or something, right? Yeah, so this is 15, and then the next number is like 7 or whatever it is, and so forth, so that you kind of, combine it to the biggest number, and that's this part. As I said during the contest, I actually didn't want to think about it. I was like, I have a feeling this is right, but I don't want to chance it, so let me just do a sorting in reverse, and after that, I just take the biggest k, which by definition will be the biggest, and then square them, and remember into mod, and then that's it. The mod shouldn't do too much, because this should only be going up to 64 bits, which I think probably sucks if you're using JavaScript, because I don't know if you have enough bits. Maybe I'm wrong. But I don't know. But yeah, so what's the complexity here, right? This is linear times alpha, where alpha is the number of bits. Yeah, okay, sure. Yeah, or you could say linear maybe, but alpha times the n. And this is also obviously alpha times n, and I think you could actually, like, in that way you could actually just start adding it here now, and then for the first k, so maybe you could just actually done this to k, and then like, something like this, right? Right, and that'll be fine. Then you skip the n log n thing, right? Is this right? That'd be funny if I just kind of make an optimization that's well. But I mean, that way he got it right, so it should be okay. Give it submit. Yeah. But yeah, so this is going to be O of A times n, or alpha times n, where alpha is the number of bits, which in this case I just set to 32. I don't think it even goes that high. Okay, it goes to 10 to the 9, which is, I guess, like 2 to the 30. But yeah, that's all I have for this one. Let me know what you think. A lot of this problem, like I think if you look at it as, someone solving in 3 minutes and be like, oh, this must be easy. A lot of it is just experience and practice and so forth. And like I said, having that experience, and it's not like a one-to-one experience in the sense that like, oh, I remember this problem, I know the exact answer. It's not quite like that, but it allows me to kind of make jumps in intuition, like saving maybe like each of the steps might have saved me, or each of the steps might have taken me 2 minutes to kind of figure out the observation about, and then once I know it, then but this time I get to save like 2 minutes here, 2 minutes here, so then now it only takes 3 minutes instead of 10 minutes, and then but yeah, that's pretty much all I have for this one. Let me know what you think. Answer is just generally greedy, but definitely if you struggle with bitwise operations, try to kind of do truth tables as you can and kind of figure that out. But yeah, and obviously if you try to maximize k elements, then it's just greedy. And here we already kind of is this kind of like radix sorted kind of by the first k. So yeah, that's all I have for this one. Let me know what you think. Let me know how you did. You could watch me solve it live in the contest now. Okay, silly mistake. Oh man, and just misreading that problem for a long time. All right, let's go. I feel like I know what this means, but I forget. I think this is okay. Okay, mod. Let's do this first. Okay, I to so what does this mean? So that means that for 1 1 nothing happens, 0 0 nothing happens, so it was 1 0. Then ij would basically give all the bits to the I. No, we'll give all the bits to the j. Okay, so I mean one of the elements anyway. So give all the bits to one of the elements. Okay, you have to. We can do all these, and then you could choose the k and then calculate some elements. Okay. Oh, this is easy then. Yeah, I can see why so many people got it. Just greedy, right? Yeah. Okay. So, what am I doing? Okay. Right, and then now greedy. Okay, and then now, yeah. Right. Okay. And then yeah. Whatever. Writing this in a sloppy way, but that's fine. The mod doesn't even matter that much, but 261.90. This times out, I'll be way sad. This is Thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem, today's contest, today's explanation, everything in between. Yeah, stay good, stay healthy, take good mental health. I'll see y'all later and take care. Bye bye.